Welcome back to our classroom. Here we are going to discuss about our in-text questions and answer. On the board I have written only the answer. The question you have to take down from your textbook, right? So let's move on to our topic. So the page number 224, question number 1. Why the compass needle get deflected when you are brought near the bar magnet? Okay. So the answer is, why it is deflected means it is due to the magnetic field around the bar magnet. So we have a bar magnet. In that bar magnet, it produces a magnetic field, right? Due to that magnetic field, the compass needle gets deflected. Yes, this question may ask in 1 mark question. And page number 228, question number 1. Draw a systematic diagram of a bar magnetic field lines. So in a bar magnet, we have south pole and north pole, and the magnetic field lines are started from north pole and reaches south pole outside the bar magnet. But inside the bar magnet, the magnetic field lines travels from south pole to north pole. This question is asked in diagram part. Don't make any mistakes. And again I am telling you. So our head is north pole, our leg is south pole. Okay. Inside means it starts from leg to head, and outside means it travels from north to south. So this is the diagram I have indicated very clearly. Be careful while draw the diagram, and you must also indicate the direction. That is very important, right? Because the magnetic flux density is a vector quantity, right? The magnetic field lines. So due to that magnetic field lines, we will have the flux density, right? That is the number of magnetic lines is passing per unit area, that we are saying that magnetic flux density, right? So these arrow marks are very important, right? So outside the magnet, it starts from north pole to south pole, and inside the magnet, it starts from south to north pole. So north to south direction, and south to north, I have mentioned the direction, right? And question number 2 is, write any two properties of magnetic field lines of forces. Okay. So again the same point I am going to repeat here. And it originates from the north pole of the magnet and it's end with south pole when it's outside the bar magnet, and it is closed and continuous curve. Remember that here this is a closed one, right? There is no gap, and which is also continuous. So it starts from north, again come back to south, again south to north it travels, right? So that's why I wrote the continuous curve. And question number 3 is, if two magnetic field lines are intersect, it is possible, they are asking. No two field lines are intersect with each other. Why? So the question is, they ask, the answer part is, suppose we have two magnetic field lines, right? For example, for understanding I am telling here. So here we have two magnetic lines of forces which intersect at a point here. That point I mentioned as very clearly as question mark. In that point, how do we define which is north pole and south pole? Can you do that? At that point, what is the north pole, which is the south pole? We cannot predict, right? Yes, that's why we are saying that no two magnetic field lines are intersect with each other. If it is intersect, at the point of intersection we cannot, and at the point of intersection it gives two different directions, which is not possible. That is the answer for those questions, right? I hope you understand well. And continuously we are doing the next answer for those questions and the next page numbers. Thank you.